4.7. Triangles and coordinate proofs. Definition of coordinate proof. Uses figures in the coordinate plane and algebra to prove geometric concepts. So again, uses figures in the coordinate plane and algebra to prove geometric concepts. There's 4 hints, just different rules that you should follow while creating the coordinate proof. Number 1, it says use the origin as a vertex or center of the figure. This is just going to make your life a lot easier if you have an ordered pair that is 0, 0. Number 2, place at least one side of the polygon on an axis. Again, you're going to have an ordered pair that's going to have a 0 in it. This will make computations easier later on. Number 3, keep the figure within the first quadrant if possible. This again, you're going to have ordered pairs that'll be all positive. This will make whenever you have to use the slope and find the slope between these 2 points a lot easier. The last one, 4, use coordinates that make computation as simple as possible. If you want to take half of a number, you might want to use even numbers in your coordinates. So you might say 2a or 4b. You wouldn't want it to find half of 7. That's just going to make it a little, it's just, you would have 3.5, but again, using a whole number that's even would be a better choice. So example number 1. So you can see that on the bottom of your page. It says position and label right triangle XYZ with leg XZ and D units long on a coordinate plane. Now, here's another useful hint. If you're just not comfortable with having D as your length, you can always plug in numbers and say D equals 10. And we'll go over more of those examples in lessons that follow. So in this case, I'm going to take down my sheet of paper and show you what I did. So here you've got a triangle, and I'll zoom in on this. I've labeled my X, my Y, and my Z. So XZ is D units long. So my ordered pair here is D0. My X is going to be 0, 0. And up here for Y, it didn't give me any stipulations. So I just called it 0B because it's on the Y-axis. 0 is always going to be in that X coordinate, where D is going to be your X intercept. So D's in your X coordinate and 0 is in your Y. So that's it. That is my positioning a right triangle on a coordinate plane. Next one. It says and states that we need to figure out all 3 of our ordered pairs in our triangle. And what they give you first, let's zoom in on this, is your R value, which is C0, and you're going to see this on your handout better clearer than you're going to see it here. Then you have S, and you need to find Q. Q is easy because that's the origin, so that's 0, 0. So now we need to look at what S would be. Right? Over here, I stated that it was going to be CD. Right? That means I'm going over C units, which is what my x-intercept or x coordinate is going to be for R. And then I go up so many units. I just labeled it D. You don't have to label it D. You can label it F. You can name it B, whatever you'd want to. That's just one possibility. But your x coordinate should be C. Then there's some other information on the bottom of your page. That's just giving you some just different things that you should do when you are writing a coordinate proof. And these are much easier than our 2-column proofs that we talked about before. It says after labeling figure on the coordinate plane, ID important properties and theorems used. So are you using midpoint formula? Are you using the fact that it's a triangle and you want to know that 2 sides are going to be perpendicular? Just like up here, this side's perpendicular to the x-axis. Theorems that are most commonly used are distance formula, right? Slope formula, and midpoint. And again, they said on the bottom, use numerical coordinates, then replace numbers with variables. So that way it makes it a little bit easier. Some people aren't comfortable with using variables. So let's move on to our next side. And we've got a few examples. So I'll zoom in on this. Okay. So it states that write a coordinate proof to prove that the segment that joins the vertex angle of an isosceles triangle to the midpoint of its base is perpendicular to the base. So whenever I see perpendicular, right, to another side, I'm always thinking slope. So we need to figure out first what this particular figure is going to look like, and then we'll talk about how we're going to find this. So here you've got your triangle, and I'll let you draw this and I'll describe as you draw. I've got my x and y axis, I've got an isosceles triangle, so these two sides, this side here, from the origin to y, and y to f, into this side over here, those sides are equal to each other. I named one of my ordered pairs 0, 0, the origin. Then this one over here, I named it 2a, 0, just because I have to find the midpoint. 2a seemed the easiest, simplest way. So then my w would be a0, okay? My y is then going to be ab. Okay? I don't know. I could have named b d or c or anything like that, but that's just the way that I did it. Now, when you're looking at my proof over to the right-hand side, first thing I did was I found my midpoint of x, z, right, and this is my z, which is a0, because I'm taking half of x, right, which is going to be a, and 0, half of 0 is always 0. Then I'm going to find the slope of yw. So yw is this vertical line right here. The slope of a vertical line is undefined. I then look at the slope of xz, which is going to be 0 in this case, because it's the horizontal line. So then I look at the two slopes, undefined and 0. I know that if those are my two slopes, they're opposite reciprocals of each other. So therefore, yw is perpendicular to xz, proving that the segment that joins the vertex of the angle of my isosceles triangle to the midpoint of the base is perpendicular to the base. Right? So why don't you pause, take a moment, and then take a look at example number 4. Okay? Again, you're writing a coordinate proof. See what you guys come up with, and when you play this video some more, I'll give you guys exactly how I solve this problem. So you guys should have taken a look at the next example, and I'm just going to read through this. Right. It states that I have a drafting tool in the shape of a right triangle, and that the length of one of the sides is 10 inches, right, and the length of another side is 5.75 inches. So I've got my E, my D, and then my origin. So the first thing that I'm going to do is find the slope of ED. Okay? So I'm going to go 0 minus 10, and then 0 minus 0. So I get negative 10 over 0. Okay? That's undefined. I then go over and I'm going to look now at DF. DF, you've got a slope of 0 over 5.5 once we figured that out. So I went 0 minus 0 in the numerator, denominator 5.75 comma 0. So 5.75 minus 0 in the denominator when I'm solving. So whenever I have 0 divided by a number, the slope is 0. So just like when we were solving the one above, you have a slope that's undefined and a slope that's 0. So these are perpendicular to each other. So the two slopes are perpendicular to each other. Therefore, triangle DEF is a right triangle.